Hey guys, this is Bharath. Welcome back to my channel. Today I want to talk about Python generators. So Python generators come in handy when you're working with large data sets. Um, yeah, when you're working with large data sets, it's easy to overwhelm your system and basically eat up all the memory that your system has. So let's actually look at how you can use generators to avoid overconsumption of memory. Okay, so first actually let me show you a couple of things. So one is, so I have a script called generate even squares, and this is, I call it a regular method. So if you look at the script, actually there is one main function. This function basically, if you pass in a number, and this is not just a number, it's a sequence. Basically it could be a list or a tuple, but it's a sequence. And then this for loop will iterate over that sequence, and then for all the even numbers that it finds in that sequence, it will basically square that number and it will add it to this list called event list. And then that event list is actually initialized to an empty list in the beginning here. And then finally, once the iteration finishes, um, once the iterations are done, then we will just return this list to, you know, to the call actually. So it's a pretty simple function, but what we need to notice is when we pass a huge range. So if you don't know range, actually range is a function that will generate a sequence, and you can pass the starting number, ending number, and so on. But if you just pass a number, so it's going to generate a sequence from I believe 0 through, and this is probably not included in the sequence, but yeah, so this is 30 million. So this is 30 million, so that's actually um, a huge sequence. So we're passing that sequence to this function, and then this function is go through that huge sequence and then find the even numbers, square them, and add it to this even list. So as you can see, this is quite a heavy function. And I have, so basically uh, I have this memory profiler package to basically keep track of how much memory I'm using. Um, so that's the memory profiler package. There's not much to understand or dig there. It's basically a package that will give you how much memory is consumed at that point in time, and we get that before and after our calls, and then we see the difference, and that way we can see how much memory we consumed actually, or this section of the code consumed. So now here I have a call to this function, and I'm passing this huge sequence, and that is going to return this huge list. And then I have another function which is, and starting with the counter, so just to actually print the first 10 numbers in the sequence, right? I just want to print the first 10 numbers in the sequence just to show you how the list looks. That's not required for this program at all, but this is the heavy, this is the line actually that does quite a heavy job actually. So, and then finally we print, we print the amount of memory that's used by this script actually, or mainly by this portion of the code, right? So let's go ahead and run it. I'm actually running this in my local my local desktop, my laptop. um, since this is a heavy script, I don't want to run it on REPL or any of the online IDE environments. They're most likely to get killed. So, but anyway, let's actually run it and see. So it's running right now, and okay, let's see what it printed actually. So it printed about 3, 6, 9, 11. So it printed like starting from, so it basically printed like the first 11 numbers in the list actually. And this output actually comes from this print command, and basically the for loop has gone through the list which is written by this function, and it printed so these many or it printed the first 11 numbers in the sequence in that list actually. And then finally it printed the amount of memory used. So it, as you can see, it says actually 483 MB has been consumed by between this part and this part. So that's, quite a lot of memory, and we are working with a large data set here, right? So now this is a typical example where you can use generators to actually avoid such memory consumption. So now I'm going to show you another version of the script, basically with a similar name, except this one's going to use a slightly different method to work with the list actually, to achieve the uh, same outcome actually, right? So we have a function, we have memory profiler package imported, we need that to track the memory usage, and I have commented out some print statements. Let's not worry about that now. So but if you look at it, so we have a similar call. We are calling this function, and then let's actually make sure we pass the same let's say 30 million, right? So that's a huge range. We want to make sure we are comparing apples to apples. So that's 1, 2, 3, yeah, 30 million. So now, so when we have a for loop here which is going to print the first 10 numbers in the list, that in the list actually, or in first 10 numbers in the sequence that comes from this variable actually, right? Okay, so let's go ahead and run this first, right? Python gen even square dot py. So this one actually, it ran pretty quick, and it printed the same output. And if you look at the amount of memory used, it's like 0 MB. I've rounded it off, but it must be like in few KBs actually, compared to 483 MB, right? Where we were basically loading so many numbers in this event list, right? So that's actually the main reason for memory consumption, right? So now let's look at the script itself. The script basically, like, this is the main part, like rest is all the same. And if you closely look at this this function, so you have an empty list, but I don't think we're going to use it. But the main thing is, so we have a for loop which is going to loop through the set of numbers that is being passed from here to here. So it's a sequence of numbers, but more importantly, what we have is a keyword called yield, as opposed to a return. We have like return in the traditional function, right? So yield is different in this way basically. So a return is basically going to return a certain value or a list or a tuple or something to the place where it was invoked, right? So but here yield uh, basically returns, this value, and it also, like, Python also remembers which value was returned, and then it keeps track of the state of the function, right? So if I call this the first time, so you can see that I'm I'm doing this, but this is not going to get a list like what happened in the traditional function. In the traditional function, we had a even list, and then we kept on appending the numbers, this number to that list. But here we're not appending any number. All we are doing is we will be getting basically a generator object. We'll be getting a generator object, and that actually goes and sits in this place, right? So because that's the same as this variable, so it's a generator object, and it's actually iterable, meaning like we can iterate over that object, just like how you would do with a tuple or a list. So we can iterate over that object, and we use for function, I mean a uh, for statement for that, or for keyword for that, or a for loop. uh, but here you you know th these print statements show that I use a next function to call the same variable, actually, to or to consume that generator, right? So that is also okay. So if you look inside this for coding, actually you will see that internally it is using this next function. But anyway, so this for is basically going to iterate over this es variable, and then it will print the first 10 numbers in the sequence, and then it will break out of the loop, and then finally it's going to print the memory and so on. But the main thing is the yield. So yield statement is so the first time we go through this, what will happen is, so let's say we're passing 0 through whatever, right? So 30 million. So first it's going to be 0, right? So the first number in this range is going to be 0. And when we get here, so what will happen is so it will go through the for loop, and then so it's going to return 0. So 0 is returned, and then so then in the next iteration 1 will be returned, but we're not loading anything in the memory. So yield is basically sending this value to the place it was invoked, but it is also remembering the state of this function, right? And then so every time it is called, it basically moves to the next value and then sends it to the call invocation location, right? So that's basically the point. So this is actually a powerful uh, tool to reduce memory consumption in your Python programs, actually. So I will actually put this both these scripts in my GitHub, and put the GitHub link in the descriptions. Please do check it out. And yeah, so this one's a quick one today, and I just want to make sure I consistently try to share with you whatever I know, right? So yep, so if you guys like my videos, please subscribe to my channel, and share the video with your friends on your LinkedIn and Facebook accounts. I really appreciate that, and thank you so much. And please do check out my other videos. I will see you in another video very soon. Bye.